Hi there, welcome to this video on the basics on circles. We'll be discussing its definition, its equation, and some fun examples involving it, especially the third one. So this is still the playlist on before college, and this is one of the things that is important for you to know upon entering college. So without further ado, let's begin. First, what the heck is a circle? By definition, a circle is a set of points that are equidistant, which means that all the points have equal distances from a fixed point, which we will call the center. And this fixed distance from the center to any point on the circle is what we call the radius. It's kind of hard to understand what circle is just by looking at the definition, so let's visualize what is happening out here. So let's say we have a fixed point out here called the center, we denote to be C, and let's say we have a distance out here which we will call R for radius. What this definition tells us is that a circle is the set of points, such as this one, wherein its distance from the center is R. So that means other points on the circle will have something like this. Again, R distance, like this, maybe like this one as well, and this one. All of this have R distances. And then you collect all of those to be able to form the circle. Yeah, it will look something like this. So this is how the circle looks like. But I think this one is pretty familiar to you because ever since you start school, circle is something that is already taught on how it looks. Just take note that technically this is its actual definition. So why did we need to emphasize that? Because that would play a role in determining its equation on the 2D coordinate system. So we have this theorem, which I think is very well known. It's called the center radius rule. So formally stating, suppose we have real numbers h, k, and r with r greater than 0 since r will represent the radius and we want the radius to be greater than 0. Otherwise, if it is negative, then we won't really be able to form a circle. If it is equal to 0, we won't really be able to obtain a circle as well since we'll just have a point. So given that, a circle with center at the point hk and the radius r has an equation of the form x minus h squared plus y minus k squared equal to r squared. And as you can see, this form might ring a bell to you. Kinda looks like the Pythagorean theorem or the distance formula, and that's actually where it came from. So as an exercise, you can prove this one using the distance formula. All you need to do is to remember that by definition, the circle is the set of all points that are equidistant from the point hk and its radius is given by r. So from there, you can easily obtain this equation. Once you have this, we can do some fun examples. First, we are to determine the center and the radius of the circle with equation given by x squared plus y squared minus 3x plus 10y minus 1 equal to 0. You may solve this first on your own before we proceed. Okay, good. So let us start. To solve this, since we want the center and the radius, might as well convert this equation to its center radius form, right? We can do that since this is just an equation and we know how to manipulate an equation. So that is, first, observe that we can rewrite this equation into something of like this. All we did is move this one to the other side and then combine the terms with the same variable. So x out here and y out here. You might be wondering why we did it this way. Well, just recall that in the center radius form of the circle, we have x minus h squared out here and y minus k squared out here equal to r squared. In other words, the ones with the x's is isolated here, ones with the y's are isolated here, and we have a constant out here. More specifically, we'll be doing a completing the square out here to obtain that x minus h squared and y minus k squared. That's why we positioned it this way. That's also why there is spaces out here. So we begin with this first one. So to complete the square out here, if you recall, all we need to do is, so for this one, well, negative doesn't really matter. You divide it by 2, so we'll have 3 over 2. You square it, and that would be the constant term that we add out here. So we'll be having 9 over 4 out here. And again, since this is an equation, once you add something on the left side, we must also add it on the right. That's why we have plus 9 over 4 here as well. We do the same for this y out here. We have 10, we divide that by 2, that's 5, you square it, you put it here, and that would be plus 25. Add here, so we add here as well, we'll be having plus 25 here as well. Now, once you have that, all we need to do is to simplify. By simplifying, we'll obtain first for this one, again, when you are already able to complete the square, you can factor it into a square of a binomial, which is given by The first term is just the square of this, and the last term is just the square of this. We determine that it is minus based on this one. Do the same for this other one to obtain this. For this constant term, all you need to do is write 1 as 4 over 4 and 25 as 100 over 4. Add these two, add 9, we obtain this. And once you have this, we can now determine the center and the radius of the circle. And that is given by, first for the center, we have the point with coordinates 3, 2, which came from this one, and negative 5, since this one can be written as y minus negative 5. So that is the center of the circle. For its radius, just get the square root of this one to obtain the square root of 113 over 2. So these are the answer for this problem. Yeah, it's kind of straightforward. The trick that is important out here is this completing the square part. So that is the game changer for us. Take note of that one, as that is a usual trick in circles and in the future in the conic section. Let's move on to the next example. Here, our goal is to determine now the equation of the circle with the facts given that it is centered at the point 3, 4 and that it passes through the point negative 1, 5. So to solve this one, you may first try this one first on your own before we proceed. Okay, good. So let's work on this problem. The first thing that we can do is to use the obvious one, which is that the circle is centered at 3, 4. So by our formula, we can obtain a partial equation for the circle. That is, again, by the formula, we'll obtain x minus 3 squared plus y minus 4 squared equal to r squared. So we use the fact that this one is the center. This means that our problem only boils down to solving for r squared. And to do that, we'll be using the other ingredient. The circle must pass through the point negative 1, 5. How will we use that one? Well, take note that the point negative 1, 5 must satisfy this equation. And why is that? Well, take note that, let's see, we have the point negative 1, 5 out here and the point 3, 4 out here. By definition, negative 1, 5 must pass through the circle. So that means that we'll be having something like this. So it doesn't really look like a circle, but assume that this 3, 4 is the center. So by definition, we know that this one is r. Or in other words, negative 1, 5 must satisfy the equation because this equation represents all the points on our circle, or that is, it represents all the points that are equidistant from the center, 3, 4. Got that one? So just by definition, we are sure that this point must satisfy this equation. By using that fact, we'll be obtaining this equation. So we just plug this one in out here, and by plugging it in out here, we are sure that this equation must hold. So that's our gateway to solving for r squared. So to solve for r squared, take note that this one will become negative 4 squared, which is equal to 16. This one is simply just 1. Add them both, we obtain r squared equal to 17. Take note that I don't need to obtain r anymore, since our goal anyways is to form the equation of the circle. So all I need to do is to plug this one out here. So to conclude, we can conclude that the equation of the circle is given by the quantity x minus 3 squared plus the quantity y minus 4 squared equal to 17. That answers the given problem. Let's move on to the last example. So for our third example, our goal is to find the equation of the circle, which is centered at 3, 4, and that is tangent to the x-axis. So this one is kind of hard to solve without drawing a figure. So let's do that one. So first we have here the coordinate system and the point 3, 4. Given that this one is the center, we can form a circle like this, like this, like this. But there is one particular that we want, and that one is tangent to the x-axis. Can you imagine how that circle looks like? It would look something like this. So this one is a circle that is tangent to the x-axis. So if you will recall, tangent to x-axis means that if we have a circle out here, this one is a point, this one is a tangent line if it passes through the circle just exactly at one point. A line may either pass a circle through 2 points or not pass it at all. So for example, this one is a line that passes the circle at 2 points, and this is a line that never intersects the circle. So this one is the tangent line. One way to view tangent lines is that they are like lines that just touches the circle. It doesn't intersect it, it just touches it a little. So in this case, this one is the tangent line and it intersects the circle at exactly 1 point, which is this one. So take note that we are sure that this line out here is perpendicular to the tangent line because that is a known fact in circles and tangent lines. So this one is worked. So given that fact, what can we say about this point? Well, this point must be the point with coordinates 3, 0. Why is that? Again, this one is a completely vertical line, which means that from this point to this point, there is no horizontal shift from it, which means that we are sure that the x-coordinate must still be 3 and it intersects the x-axis, which means that its y-coordinate must be 0. That's why we have this. And once you have that, you can easily determine the radius, since we know that this one represents the change in the y of this point to this point, and this one is at 4, this one is at 0. That means that the radius must be equal to 4. Now that we have this, we can now form the equation of the circle. We have the center, we have the radius. So stating that one out formally, note that the center of the circle again is given by this point, and it has radius 4 units. Applying this to our formula, we can conclude that the equation of the circle is given by the quantity x minus 3 squared plus the quantity y minus 4 squared equal to 16. 3 and 4 came from the center, 16 is just equal to 4 squared, which is precisely the radius. So that finishes this video. Just some final word out here. So if you haven't checked it, I have a feedback form in the comment section or the description down below. So please help me provide better math content to you by answering this Google form, as it would be helpful for me to adjust the videos that I make in such a way that it would impact you and your studies in math. If that is too tiring for you, you can just comment it down below and I'll be glad to read that one. Yeah, so that's it. I hope you enjoyed that one and have a nice day.